All right, let's continue our discussion of probability by looking at overlapping and non-overlapping events. We're going to start by looking at using a standard deck of 52 playing cards. We've talked about this, and let's talk about non-overlapping events. Non-overlapping events are events that cannot occur together. So, for example, if we're looking at a deck of cards and we want to pick a black or a red card, but not both, they are non-overlapping. Each card is either red or black. Okay. Just another example of an event of non-overlapping conditions from a deck of cards is you can draw a face card, and that's card, and you can draw a 7. Okay. Those are non-overlapping. It's either a face card or it's a 7. It can't be both. Now let's compare that to overlapping events. Overlapping events can occur together. So when selecting a single card from a deck, the events Queen and Heart are overlapping because it can be both. So if we go back to what we did before with our Venn diagram, your overlapping event is this area here that belongs to both sets. Okay. These queens are not hearts, these hearts are not queens, but there is one queen that is also a heart. Another one that you could think of from a deck is draw a red card and draw a 7. 7 seems to be my number for today. They are overlapping because you can have a red card that is also a 7. Okay. All right, well, of course, there are new formulas for these, and if you have non-overlapping events, the probability that A or B occur. Remember, our other ones was and. These are or. The probability of A or B, you just add the probabilities together. If they are overlapping events, A or B again, you have to add the probabilities of each event, but then subtract out. This is the overlap. You have to back that out because it's being counted in one event and counted in the other, so you have to subtract it out. Okay. Now, as we look at these, we're going to look at them in two ways, and you're going to decide which way works best for you just from a visual standpoint. So we're still looking at a standard deck of 52 cards. So I have got a standard deck of 52 cards here. Can a single card be a king and a queen? Well, let's see. If we have kings and if we have queens, and I don't know why I wrote them in that order, what you've got here are non-overlapping events. Because in here you have the king of diamonds, the king of hearts, you have the king of spades, and the king of clubs. You have the same thing for the queens. You have the queen of diamonds, you have the queen of hearts, you have the queen of spades, and the queen of clubs. Okay. So the answer is no. It cannot be both a king and a queen, which means they are non-overlapping. Okay. Okay, so you can also look at this in terms of your cards. You can just look at your deck of cards, and of course here you have our kings. And here you have your queens. There is nothing that belongs to both sets. Now, I should have done this on the first page, so I'm going to go back and make sure we illustrate it here. If you see here, you have queens and hearts. Here you have your queens. Here you have your hearts. And you can see that you have an overlap here of the Queen of Hearts. Okay, sorry I forgot that. Okay, so what is the probability that a card is a queen? Okay, well, the probability that a card is a queen, there are four of them out of 52 cards, which reduces to 1 over 13. The probability that it's a king is 4 out of 52, which is also 1 out of 13. So that it's a probability of a queen or a king is the probability of a queen, which is 1 out of 13, plus the probability of a king. And when I total that up, of course I add the numerators, that becomes 2 out of 13. Okay. All right, now we are going to imagine drawing a single card from a deck of 52. Can a card be simultaneously a red card and a king? Okay, well, let's look at our red cards here. So here are our red cards. Here are our kings. And you can see that we have an overlap here. The King of Hearts and the King of Diamonds belong to both sets. Now, once again, can it be both a red card and a king? Yes. If we can also illustrate that with a Venn diagram. So we can do red cards and kings. Red cards, there's no way I'm going to list them all in here. But kings, you're going to have the King of Spades and the King of Clubs out here, but inside you are going to have the King of Diamonds and the King of Hearts, and this is going to be our overlap. Okay. So these are in fact overlapping events. It can be both of them. Okay, so what is the probability that is a red card? Well, if you look at this, there are 26 red cards out of the 52, which is 1/2. What is the probability of a king? There are 4 kings out of the 52 cards, which is 1 over 13. Okay. So, what is the probability that the card is a red or a king? Okay, well, we have to add these together. The probability of a red card is 1/2. The probability of a king is 1 over 13. But now we have to subtract the overlap. So this must be subtracted. So there are 2 out of 52. Now there are a lot of different ways to look at this in terms of adding it up. If you'll notice, before I reduced the fractions, they all had the same denominator. So I think I'm going to add them using that strategy. I'm going to say, okay, well, I've got 26 out of 52 plus 4 out of 52 minus 2 out of 52. And of course, your calculator can help you with that as well, which gives me 28 out of 52. Okay, now let's look at our outcomes of rolling 2 dice together. Okay, so this game consists of rolling 2 fair dice and adding the results. Okay, the diagram down here, and I've put it for each problem so you can draw on it, lists the 36 equally likely outcomes that are possible when rolling 2 die and summing the results. Okay, so let's consider the events rolling a sum of 7. Okay, so if I have rolling a sum of 7, here are all the outcomes for rolling a sum of 7 and rolling a sum of 11. So here are the outcomes for the sum of 11. Are these overlapping or non-overlapping? Well, they are non-overlapping. And to explain that, you can say the sum cannot be both a 7 and an 11. Okay, so we want to find the probability that the sum is 7 or the sum is 11, which tells me I just add those two probabilities from the formula. So that's the probability of 7 plus the probability of 11. Well, the probability of a 7, there are 1, 2, 3, 4, 5, 6 out of 36. The probability of an 11, there are 2 out of 36. If I add those together, I get 8 out of 36. And when we're doing these, I don't care if you reduce the fractions or not. That, a lot of times it's just easier to deal with and easier to see your results if you leave the original denominator. Okay, let's try another one. Consider the events roll an even sum and roll a sum larger than 9. Okay, so let's do an even sum. Okay, so that is any even sum. So 2, 4, 6, 4, 6, 8, 4, 6, 8, 6, 8, 10, 6, 8, 10, 8, 10, 12. And we're also going to look at a sum larger than 9. That means 10 or more. So we've got a sum of 10, a sum of 11, and a sum of 12. These are overlapping events because you can see you can have a sum that is even, that is larger than 9. So the ones that are overlapping are the ones that are colored with both numbers. So I have 1, 2, 3, 4 overlapping events. Okay. All right, so here's what I need to do for this. So the probability of an even or larger than 9, the probability of even or larger than 9 is going to be the probability of an even plus the probability of larger than 9, and I have to subtract out the overlap of the probability of even and larger than 9. Okay, so what does that give me? So the probability of an even sum, so that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Well, it should be 18. Did I miscount? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, I just can't count. So this is 18 out of 36. The larger than 9 is 1, 2, 3, 4, 5, 6 out of 36 possible outcomes. And then I have to subtract the 4 out of 36 overlapping events. And what that gives me is 20 out of 36. Okay. Consider the events. Roll 1 on the first die and 1 on the second die. Are these overlapping or non-overlapping? These are overlapping. Okay. All right, so let's see. Let's look at a 1 on the first die. And again, if you don't see it, that's fine. 1 on the first die is all of these. One on the second die, you can fill out the table first before you answer that question. That's the 1 on the second die. And then our overlap is right here. So I have 1 overlapping event that must be backed out. Okay. So the probability of 1 on the first die, or 1 on the second die is the probability of 1 on the first plus the probability of 1 on the second minus the probability of 1 on first and second. Okay, so the probability of 1 on the first is there are 6 out of the 36 possible outcomes. On the second, there are 6 out of the possible 36 outcomes. And then we have to subtract out the 1 out of the 36, and that gives me 11 out of 36. Okay, let's do a couple more problems real quick. Okie dokie. Okay, you select a person at random from a group of 8 total people made up of 2 Democratic men, 2 Democratic women, 2 Republican men, and 2 Republican women. Okay, what is the probability that you will select a person who is a Democrat? Okay, now there are a couple ways to look at this again. All right, you know you have 8 total people. You could even make a little chart if you wanted to, if this would help you with a visual. Okay, so you know that you are dealing with men, women, Democrats, and Republicans. Okay, so you have 2 Democratic men, 2 Democratic women, 2 Republican men, and 2 Republican women, for a total of 8. Okay, what is the probability that you will select a person who is a Democrat? Okay, well, the Democrats, so the probability of a Democrat is going to be 4 out of 8, which is 1/2. The probability of a female, well, there are 4 out of the 8 possible, which again is 1/2. What is the probability that you have a person who is a female and a Democrat? And a Democrat? Well, there are 2 out of 8, which is 1/4. Okay, what is the probability that you will select a person who is a female or a Democrat? Okay. Well, here, this is going to be an overlapping event. Because if it's a female or a Democrat, there are elements of both. So the probability of female or Democrat is equal to the probability of a female plus the probability of a Democrat minus the probability of female and Democrat. You never knew how and or were such important words. Okay, the probability of a female, and again, I'm going to use these that all have the same denominator, is 4 out of 8. The probability of a Democrat is 4 out of 8. And the probability of a female and a Democrat is 2 over 8. So 8 minus 2 gives me 6 over 8, or 3 over 4. And again, 6 over 8 is just fine. Okay, suppose you are selecting one ACC student at random from a large list of ACC students. What is the probability that the student was born in the month of December? We had done this before, so we have to use in terms of days. So the probability of December is 31 days divided by 365. There are 31 days in December, 365 days in the year. Okay. All right, well, what is the probability that the student was born on a Monday? Well, there are 365 days in the year. There are 52 weeks, which means there are 52 Mondays. Okay. Are the events born in December and born on a Monday overlapping or non-overlapping? They are overlapping because you could be born on a Monday in December. Okay. All right, now for this, we want to find the probability. Now we know the probability of December or a Monday is going to be the probability of December plus the probability of a Monday minus the probability, oh, I ran out of room, December and Monday. Okay. Well, we know what each of these is. The probability of December is 31 out of 365. The probability of a Monday is 52 over 365. And since they are overlapping, we're going to have to subtract out that duplicate, and we end up with 78 out of 365. Okay, the end. Next video will be for 7C. Bye.